So I'm just looking at a fairly straightforward repair, I hope, this morning. This power supply has failed. It was I found it in the part bin at work. Somebody just thrown it away, doesn't want to repair it, and clearly the 4 capacitors have seen better days. So I guess I'm hoping that it's just a change of capacitors and it'll breathe a bit more life into this. It's quite a chunky little 5-volt power supply. Give a look at the specs on here. Yeah, XP power, 12 amps at 5 volts, so 60 watt power supply. So looking closely at these capacitors, you can see some of them have got a little bit of a red sort of bead in the top, suggesting some of the goo might have come out from inside. Certainly this one here at the bottom, you can see some horrible gooey stuff, and it looks like it's exploded at the underneath. I mean, these ones, like most capacitors, electrolytics are scored on the top as a little bursting disc, and they should give way here first, but I think this one has decided to poo its pants rather than sort of explode out of its head. Anyway, let's just get these 4 removed and replaced and see whether it works. You can sort of see why companies where money is time is money, that they don't repair things like this. Hopefully if I bring in a little bit of that noise down as well. Sorry, I'm not using the solder socket at the moment. You can see the bottom end of that can is all extruded rather than being a flat base. At this point here I'm talking about here, it's all sort of extruded and got some gooey brown mess. But the top of the can is fine, it's flat, can't really see any upward bow at all. So really, yeah, capacitor shouldn't fail in that direction. It should fail in that direction. Anyway, let's remove the other 3 and see how we go. Okay, I've pulled those 4 out now. It was a little bit of a struggle, particularly down here, because it's really tightly packed in with the connector here in the transformer, but I managed to get those out without too much problem. I'm going to have to clean up the board. There's obviously some goo down here. I'm going to have a close look at the board as well to see if I can see any other problems. Of course, I'm just hoping it was the capacitors that have sort of dried out and given up the ghost. It could also be some other problem, so I might just check this very silicon here. Also do a good visual check top and bottom. Clean everything up down here in terms of the solder that I pulled on too. Make sure there's no bridges. And then, yeah, pop some new capacitors in there and see whether we can get it to work. So everything's cleaned up quite nicely. I used solder wick to remove the excess solder mainly from the underneath. A little bit of extra flux was also required. That's all been cleaned off now. I've used some acetone to clean it off. It's ready for the new capacitors to go in. Before we do that, let's just do a check on just take that off there. I'm not going to test the really crusty one because it's just dead as a door now, but these ones which are only sort of slightly bulged at the top, I've just tested these, and let's get the leads the right way around. Bring that into view, press the button. And whilst they've not actually completely failed, it's showing a very fraction, maybe 10% of its normal capacitance, so that's definitely gone. Now just to make sure the meter's working and I don't put duff capacitors in. Now these capacitors, I've just got them out of my sort of parts bin. They're not expensive capacitors, I just bought them in a kit from China. So yeah, the make on there, JWEO, or Juo, who knows, but they are physically the same size. These are rated up to 16 volts, whereas the other ones are 10 volts, but that should be okay. And if we do a quick check on that one. Yeah, so let's say millifarads, 2.1 millifarads, that's 2100 microfarads. So yeah, just slightly under spec, but these capacitors, I say, are 1800 at 10 volts, and these are 2200 at 16 volts, so this should be okay. These capacitors, I tried to look them up on the internet, and yeah, it's not usually, I draw blank, but I did with these. I can find Samsung's details and some PDFs and what have you of their products, but I can't find this X8A, or what's the other coding on there? We've got GC open brackets M. Yeah, I can't find any references to that, so I'm hoping it's not a low ESR capacitor, because I think these capacitors are just sort of fairly standard cheapies. Anyway, let's get them put in and see whether it works. Now to test this, need to get this connected up to the mains, which I'll just do a temporary connection. And in terms of the output, I've looked up online, and for this one, the two top pins here are positive, middle two are negative, these bottom two are not connected. Okay, bidgy bodgy, very dodgy. I've just wired up some mains here. It's not switched on. I've even used an American lead here, so it's really bodgy. Put white on the live, black on the neutral. Can't even remember if that's the right colours. Brown and blue where I come from. Anyway, here we go. 1, 2, 3. Okay, switch is on. Nothing went bang. Let's do some checks very carefully. No LEDs or anything to indicate anything. Let me just zoom out. Come on, focus. Lazy focus. So it was neutral and black in the middle, rather negative, and there we go. 5.4, a little bit high. Looks like there's a trimmer pot there to trim it down. Maybe do that. So yeah, that seems to work fine. So yeah, we've got a power supply which brand new from, I just had a look in RS and Farnell, are at 70, 80 Australian dollars. So not a cheap little thing. Looks like we've got a repaired one. Okay, whilst we're still here though, I'll just push that out of shot. So I'm still very wary of the fact that the mains is not very safe. So yeah, that's showing 5.4 volts. Let's see if we can't tweak this down. 5.3, 5.1, 5.05. Just bring that back into the shot. There we go, 5.05 volts on the output. Super, great.